Good morning, all of you. This is Reddemma, Assistant Professor in Annamacharya University, Rajanpet. Today we have to discuss about the deep learning topics. Introduction of deep learning, convolutional neural networks in pooling, max pooling, and average pooling. What is deep learning? Deep learning is a subset of machine learning that focuses on algorithms inspired by the human structure and function of the human brain, called the artificial neural networks. It is enable computers to automatically learn complex patterns from large amount of data, often achieving a human levels or even superhuman performance in tasks like image recognition, speech processing, translations, and playing. Here it is showing a Venn diagram of deep learning. What is the relation between the artificial intelligence, machine learning, and deep learning? Artificial intelligence is just like a human activities. Machine learning is a training process of machines to provide the algorithms how to act just like a human brain. Deep learning is a process of to future improvement process. Particularly today we have to discuss about the convolutional neural networks in pooling methods. First we have to discuss about the what is pooling. Pooling is a convolutional neural networks is a downsampling operation used to reduce the spatial size like height, width, and length of the future maps while keeping the importance information. It makes the network faster, more efficient, and less sensitive to small variance in the input. Here, two types of pooling methods are there, max pooling and average pooling. What is max pooling? Max pooling selects the maximum value from each local region of the future maps, reducing spatial dimensionality and keeping the most important features help to reduce the computations and make a convolutional neural networks robust to small transitions. We have to see the how to calculate the pooling works. First, we have to consider a 4 by 4 matrix. It is a raw data set. We have to apply the max pooling states. You have to divide into 2 by 2 matrix from input data 4 by 4 to 2 by 2. Apply 2 by 2 matrix pooling with a state 2. We have to divide the equal parts of data set. It is called a block 1, block 2, and so on, block 4. First, we have to calculate the block 1 values 1, 3, 5, 6. In this 2 by 2 matrix, here it is the highest value 6. That's why we are taken max value or 6. Second block 2, 1, 7, 8. In this 2 by 2 matrix, here it is the max value of 8. That's why we taken max value 8. Here process the new data set 6897. It is the output of max pooling state 2. Here we have to find the 4 by 2 to 2 by 2 matrix. What is the meaning is data set is large amount of data set into small amount of data set. Reduction of the data size. Here it is the advantages of pooling. Extraction strongest activation, and second one is reduce the computational cost. Third one improves the generalization, and fourth one is help build the deeper CNNs. Next one, average pooling. What is average pooling? Average pooling is a computes the average of all values in which local regions, for example, 3 by 3 windows of a future maps, and that average becomes a single value in the output. There is a reduction spatial size while summarizing the information. We have to see the how to calculate the average pooling. Suppose we have to take an input data set or input map 4 by 4 matrix 2468135702461111. We have to divide it into two blocks. Block 1, 2, 4, 1, 3. Here, how to calculate the average? Total number of values divided by number of values equal to average. Here we find the average of first block 2.5 and so on. We have calculate block 2, block 3, block 4. Same method. Finally, we got the output data feature map 2 by 2 matrix. It is the average pooling. Advantages of average pooling. First one provides the smooth representations, and second one good when you want to preserve a general context of a back propagation or background information. And third one reduces the model complexity, less computations or memory size. Fourth one can help the when you want less sensitivity to noise or outliers. Thank you.